Hello guys, in this video I will make you understand what is database replication and I will try to keep it as simple as possible so every one of you will understand what database replication is. So let's start. So the first thing is about replication. Let's understand why do we need even replication. Okay, so let's suppose you have an application and for your application you have a database. So whenever your application serving any data, like you are requesting a data and getting a data, your application will get it from the database and give it to you. So that's fine with one instance of database when you have lower traffic. But let's suppose you have built something really great and lots of users are using your application. Now the user traffic increased a lot, so one instance of database may not be sufficient for you. So what would be the next step to scale your application to increase so your database can accept all of this load? You might be thinking about vertical scaling, like increasing the RAM or CPU where your database server is, but it's fine. But it's not that efficient when you have much bigger traffic. So you may need replication. Now we will understand first. Okay, so now that you have lots of traffics, you need multiple instances of your database. Now you can see that we have three instances of our databases. There are three servers of our database, and requests are coming to all of these three servers. But here is an issue with this thing. So our database is in persistent storage, right? So let's suppose one user is making a change to a database 1. So it's not reflected to the database 2 and 3, right? So we need to fix our database in a way so we can handle this issue, right? Because we cannot see like database 1 is handling other requests, database 2 is handling other requests. But here is an issue, right? Right now, if we let user uh, have the same data among three servers, multiple users can make changes to multiple servers, right? So the data will not be consistent through all of these servers, right? So we need to fix it. How we will be fixing it? So we can fix it in a way. So among three database instances, we have to define one as in our leader node. Okay, so let's suppose right now I am choosing second node as in leader node, and the rest of our nodes will be follower. Here is a follower 1, and here is our follower 2. So right now, how we will handle this user traffics is that, okay, so right now among three database servers we have two followers and one leader, and this one leader will accept only writes, but all of these three servers will accept read requests. Like you have select queries can go through all of these servers, while your writes can be accepted by only one databases. So how this is helping us if our one database is accepting all of these writes? So whenever your write is happened by a leader node, it is replicated to all of these follower nodes. So even though our write has been done by the database, we will we will see it on the all of the database instances, right? So that's how it helping. So this will be replicated and this will be data will be replicated. And now for read request, we can read from multiple instances, and from write we can write from one instance. So this is what replication is. What you are doing, you are replicating data through all of the nodes. Okay, but this has some downsides. Right now, this is called leader based replication, because we can see that there is a leader node, and leader is replicating all of the data to all of the followers, and then we will be able to read the data. There are also other kind of replication, leaderless replication, where multiple write request can be accepted by multiple nodes. So for For leaderless application, we don't have specifically one node for the writes. We have multiple roads, multiple nodes to write. So so this is what leader uh, this is a leader based replication, okay? Because you can see leaders can accept writes and replicated the data through all of the followers. So our read requests are efficient right now, but our write requests to our databases are not that efficient, because all of this write load is affecting on the one specific node. So the downside of this replication strategy is we have only one source of truth. So what if our leader falls down and all of the data, and if our data is not replicated through our followers, then we might lose our data. So in this case, what databases do? Databases can start whenever a leader node goes down. Databases will start will start a quorum or a voting election to make the other followers to get elected as a leader. So let's suppose in our three databases, we have three instances of databases. Right now, the database 2 is down because of the heavy load. Now, there will be a election will go on among follower 1 and follower 2. And from those two followers, one will be selected as a leader, and then it will start act as a leader, and the rest of this other servers will act as a follower. So right now we are down with this leader. Now this will be moved as in leader, new leader, and this will be moved as, this will stay as follower, right? And this will again, this will go on and on. Whenever our leader goes down, election will start off, and then the datas will be replicated. And this is the this is a one type of way to fixing this kind of issue with the leader based replication. Also, there is other issues with this replication. Right now we can see that is one database is handling all of this write requests, so our write requests are not scaling out, right? So user will not see the efficient writes. Let's suppose you have an application which has greater lots of writes but lesser reads. Okay, so in this case, the writes in this case, leader based replication may not be suitable for you. So this is the case. Leader based replications are fine when you have reads greater than writes. So what is the one way to fix it? We have leader less replication. This is leader based replication. And now we will move it to the other kind of replication, which is leader less replication. Inside leader less replication, so the writes are accepted by all of these nodes. So then how will we get the consistent data? So in that case, we won't be getting the consistent data, cause we are making sure that writes are enabled by all of these nodes. To get to the point where all of the nodes can see a consistent data, it will take some time. So in that case, we will get the eventual consistency. Right now we have increased our write access, but we are reducing the, okay, so this is a leader based replication. And a same kind of replication, if we so for the case of leaderless replication, write can go through all of these instances. uh, for leaderless applications, write requests can be accepted by all of these nodes 1 2 and 3, all of these nodes. So how will we get to see the consistent data? Because at the same time, this database and this database's data can get updated. So how we will get to see a consistent data? For this case, leaderless replications, what they do, this kind of databases do a quorum call. In that quorum, they starts a vote about what the data that they have, and based on the vote, they get to see what will be the expected data, and they define it using, there are lots of ways to define it. The ways are, so based on a gossip protocol and a quorum call, they will they will get to a conclusion where the user what the user will see as in data. And now we are so Apache Cassandra. Apache Cassandra is a kind of database that uses a leaderless replication. It uses gossip protocol, and it's actually eventual consistent. We may not see the data as soon as the write has been done. It would take some time to read the data which has been updated. So that's why it's called eventual consistent. So right now we can differentiate between two of these replication types. One is leader based, and what is one is leader based, and one is leaderless replications. So right now we can see that leader based replications are efficient when you have reads requests, when you have lots of read requests, and leaderless replications are suitable when you have lots of write requests. And other than this, leader-based replications are followed by DynamoDB, your normal ACID-compliant databases like Postgres, any other database. And leaderless replication is followed by Apache Cassandra. And there are lots of other protocols also for replication. There are lots of strategies. Like for DynamoDB use a master-master replication, which is also called as an active-active replication. In DynamoDB's case, DynamoDB uses one leader as per all availability zones, and all of these other nodes per zones will be the followers. And DynamoDB can have multiple masters across all availability zones. So this is how DynamoDB works. Every database has their own kind of ways and strategies to maintain the data and get through the strategies. You can read them online, their blogs. It will be really helpful for you. So right now we are done with replication, the types of replication. Now we will move forward to the problems we have about replication. Okay, before going into the diving into the problems of replication, we can first move into the how replication has been done. Right now we can see that the leader has to replicate it through the followers. Now we will move to synchronous and asynchronous replications. So whenever let's suppose you have two nodes, okay, your leader one and follower one. So whenever you are accepting a change into the leader node, your leader node will replicate the changes to your follower node. And then when follower node is done uh, accepting the changes, done making the changes, then you will say to your user, okay, we are done with this write operation. So this is called synchronous replication, because we are making sure that okay, right now the leader has the data, follower has the data, both two of the nodes has the data, so we can proceed for further. This is good when you have less amount of servers. Right now we can see we have only two servers, databases servers. So this is fine. This won't take much time. But let's suppose you have 4 or 5 followers. This won't be efficient, right? Because your leader need to make sure all of the followers has done making the changes, and then you will return it to the user. Okay, we are done with the operation. This is not efficient. Okay, this will maintain the strong consistency, and this will make our data highly available. If lots of the nodes go down, there will be nodes who have our data, but still it can make our processes slower. It can increase the latency. So what we will do, there is also other kind of replication which is asynchronous. In asynchronous, if we move back to this this request. This if we look into this request, if we take a look at this second follower's replication, this is not being acknowledged by the reader. This is acknowledged asynchronously. Because we are not waiting for the follower to get to make the changes visible and then we are moving forward. We are not actually doing this. We are proceeding with what we have, and then we leave the rest of the data changes up to them, and they will eventually get the data updated. So this is called asynchronous replication. In this image, we can see that uh, in leader and follower 1, there is synchronous replication going on. But for follower 2, there is a asynchronous replication going on. Because we are not waiting for the acknowledgement, but we will leave it to the follower 2, and eventually we might get to see the data gets changed. So this is the suitable replication strategy, one synchronous and one asynchronous. This will be and this can be changed what your application needs. uh, what acknowledgement do you need? One acknowledgement, all acknowledgements, non acknowledgement, fully asynchronous, half asynchronous like this picture, or fully synchronous. Based on your application, you will be following this kind of you will be following replication strategy. Okay, but here is a issue we can see with this replication strategy. Let's suppose your user 1234 is updating their image. Okay, and its data gets updated at the leader node and at the follower node, and then the data gets acknowledged and the user done with the right operation. And what if user comebacks at this point? At this point, user comebacks again and make a read request to view this image that he or she has been updated at the follower 2 node. But he will not get to see the data because we can see that follower 2 has not been done yet with the replication, because it has to be done, it will be done after few times. So if in that meanwhile, if any request comes, user will not be able to see their rights, right? They will not be able to see the updated data. So it's a very bad kind of user experience. So we need to make sure that whenever we are making a write request, the the continuous requests will be go to the same servers. And how we will make sure that? We will make sure of that uh, using sticky sessions. The sticky sessions will help us to route the traffic to the same nodes. So whenever user is making changes to the leader nodes, it will again go to the same node to see the also it will go to the same node for also the read operations. So if the user is making the same request at this in the same time but at the leader node, he or she will get to see the updated data, because we can see that our data has done change, because we can see that our data replication is done. So now we are good to go. We can also use hash based routing. Let's say if we can maintain a hash of a specific user, and we will redirect the requests to a specific hash to a specific node, and then we will make sure that a specific set of users will this will help us for multiple leader replications. And when the data is getting replicated from one server to another server, there are lots of types of there are lots of when the replication is being done. Now we will deep dive into how leader nodes replicate all of the data among follower nodes. So there are multiple strategies of replicate replicate the data. The first one is statement based replication. So what is statement based replication? Let's suppose you have a leader node. Here is your leader node and your follower node. Hmm. This is a follower node. Whenever a write operation is happening, so the leader will pass all of this log of statements to its followers. Like whenever a write happen, like a insert command, it will pass out the insert command. If it's writing any update data, then the update log will be there. So that's how the statement based replication works. But the downside of this statement based replication is, let's suppose you have a SQL query where you have operations like now. Now is now function is called in SQL when you need to like get the current data. So this will be different for this node and this node, cause whenever your data there will be a replication lag, right? The now the value for now in the leader node may not be same as in the follower node, but this will lead us to the data inconsistency, right? Also for like a rand function, it will give a randomized value, where a leader node will generate a random value and a follower node will different a different random value. So we cannot uh, we cannot use this, right? Also, let's suppose there is a auto incrementing operation where leader node has the data and it's auto incrementing the data, but let's suppose follower is not up to date, but it's auto incrementing something, then it will also lead to data inconsistency among across the nodes. So these are the downsides of statement based replication. We have also another kind of replication called wall shipping. To understand wall shipping, we need to understand what a wall is. Wall is a ahead log. Write ahead log. So whenever a database, like you can think of Postgres actually follows this. So so before performing an write operation to the actual data, what Postgres first stores this write operation into a append only log file, and then it's do the write operation with the data. So that's what wal is. Wal stores byte sequence of your data in a file, and where it has all of this memory locations. Like it's a log of physical physical representation of your data. Like your data will be stored as in byte. Okay, so for wal shipping, we have the same structure, the leader and the follower node, but instead of passing the statements to from leader to follower, what we will be sending to the follower is that we will ship our wal. We will ship the wal, the append only log file, to the follower. So the downside of wal shipping is, let's suppose so the down so the downside of wal shipping is your log file is actually tightly coupled with your physical storage engine. Like you have deployed your leader node into a separate virtual machine and follower node into a separate virtual machine, right? And they might not have the same underlying physical structure. They might have different structure of storage representation. So so the replication will not work here. Also, let's suppose there is a version mismatch among your nodes, like your leader node is in version 1 and your follower node is in version 2. So so in this case your byte sequence representations can be changed, so this wall will not work also in this case also. So this is followed by Postgres, and so we have successfully understood two types of replications, like one with the high level one with the high level representation of replication and one with the low level representation of replication. Now we will move into logical replication, which is also called row based replication. So in this case you have the same structure. Hmm. So you have the same thing over here, also the leader node and the follower node. Instead of passing your instead of replicating data through your wal file or your statement based log file, this uses logical representation of your row. Like when if a node if the leader node is updating a data, Then it stores row level information of the data in a log file, and then it passes on to its follower. Let's suppose it's doing an insert operation. Then it will store an information which is needed for the row. For the insert operation, row level information, like it can be the actual data. Instead of using the commands, SQL commands, it will store the information of the row, the actual data representation, and then it will pass it to followers. And in the case of like delete operation, it will store the amount of informations which is needed to show that this row has been deleted. Also for the same case for the updates. So this will be shipped from one node to another in case of this kind of replication. This is better than in some cases this is better than while shipping, because it's not tightly coupled with the underlying storage. Also there is another kind of replication, which is trigger based replication. So right now you know that we are storing any information and we are passing it to the followers in case of in the case of um, fetching all in case of replicating the data. But this might be not efficient for your application use case. Let's suppose you are building something and you cannot accept the writes or reads according to the log file or an information. You need a custom code of your application. So then this kind of replication will be there. Instead of passing all of this kind of strategies, instead of using this kind of all of this three kinds of strategies, trigger based replication uses application code, and based on the application code's condition, the replication will happen. So this is what replication strategies looks like. Multiple databases follows multiple strategies. Based on your application needs, you can pick your strategy which will be suitable for your app. So this is all about replication. I hope you guys have understood what replication is, what are the pros and cons of replications are. I hope this video helps. Please share it with your friends.